Okay, we got question number 4. Now there is a map which is actually drawn on a grid. Now the grid consists of certain division of squares. Now this is not the exact figure, this is an approximate figure. Now you have squares inside. Okay. You have squares everywhere. So just imagine that all of these are actually squares. Now you have to look for the correct matching parts, because some of the squares will be like this, right? But if you go along, you will exactly see the corresponding part for this somewhere over here. So you got to consider this and this as one square. So you have to be you have to be cautious in counting the squares, because that will be one of the questions. For this part, you have point L and point M, and what is given here is the map is actually map of an island drawn on grid of 1 cm of squares. So this is the data given. So all of these squares are 1 cm. So if you have a square like this, this is 1 cm in dimension. Okay, so what they are asking us to find here is find the length of LM. Now this is the distance between L and M. Now between L and M you will find 8 squares present. So this is 1, 2, 3, 4, 5, 6. I need to have one more. 6 probably. I'll just place one here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you have to count these squares. So what you need to do, count the number of squares between L and M. That would give you the length of LM. So in this case it's going to be 8 cm. That's the solution for this question. Okay, let us move on. Now estimate by counting the area of the map in the diagram. So this is the second question. Estimate by counting the area of the map, right? So what are you expected to do? You're expected to count the number of squares. So the solution is going to be count the number of squares. If you were to count, you will find that there are 45 squares. Now you are asked to get the area. Estimate by counting the area of the map. So therefore the area is equal to 45 times, each square is 1 cm. That means you have 1 cm length and 1 cm in width. So you will have to multiply it by 1 cm square unit. So that's going to give you 45 cm square units. And what is this? This is going to be my area. So let me write that down there. 45 square cm. So that is the conclusion for this question. So let's move on. Now this is the next question. On the island the actual distance LM is 20 km, 20 kilometers. Now we are asked to complete the following statement. So what is the statement? On the map, 1 cm represents dash km. So we have to get this. Now what is the answer? We know that LM is equal to 8 cm, but actually LM is equal to 20 km. So this means 8 cm on the map is in reality 20 km. So that means 1 cm on the map will be 20 divided by 8. Okay, so solution: on the map you can reduce this. 2 divides here, or 4 divides here, 5 times 4 divides here 2 times 5 over 2, which is nothing but 2.5 km. So the completion of the statement is on the map 1 cm represents 2.5 km. Okay, so 8 cm is the distance of LM. So 1 cm is 2.5. So if we were to multiply 8 with 2.5, so we would get 20 km. So the distance between L and M would be 20 km. So on the map, what is happening? We are actually reducing the distance so that we can visualize the actual reality in the dimension that can be easily be represented on the map. So next one is write the scale of the map. So we call it as scale, right? If you were to reduce the dimension from 20 to 2.5, that's actually a reduction in the dimension. And this reduction, where we have 1 cm is equal to 2.5, is actually what is called as a scale that is used to draw the map. So that's also a very important technical terminology that you will have to know. So write the scale of the map in the form of 1:x. So we need to do that. So how do we do that? Now solution: the scale used is 1 cm is equal to 2.5 km. So that means 2.5 km, if I were to represent it in cm, then I have to be multiplying that value with 100,000, right? So that in turn means x is equal to, so 1 0 goes off, so 1 2 3 4, so 2 5 1 2 3 4. So this is the cm. So that we can write it in this fashion: 1 cm is nothing but 250,000 cm. So that's the solution for this question. Now this is, when you look at it, it looks really Herculean, right? So that's why That's why we come to this point where 1 cm is represented as 2.5 km. So this is more manageable when we have a look at it, whereas in this case the number looks really of huge magnitude. But this is what is expected, and we have got the solution. So now we have the next part of the questions. So let me write that question down. What distance on the island will be 3 cm on the map? So we need to calculate this. So can you guess can you try the answer? What would be the equivalent of 3 cm? So 3 cm is given, so we are expected to find what exactly this 3 cm represents in the real time. So this 3 cm is nothing but 3 multiplied with 1 cm is 2.5 km. So we multiplied by 2.5. So what do we get? We get 7 km. So 3 cm on the map will be 7 km on the island. Okay, so that's the solution, and we got one more to go. So this is the next one. The question is, what area on the island will be represented by 3 cm squared on the map? So what they're asking is, if you are representing an area by 3 cm squared, in the real world, what would that area look like, or that area be equivalent to? So the solution is given as follows. So we got 3 cm squared. Now 1 cm is equal to 2.5 km. So this in turn would mean 1 cm squared is going to be 2.5 raised to the power of 2. Right? You need to square it for area. So this is going to be equal to 3 times of 2.5 squared, which is nothing but 3 times of 6.25. You multiply this, you get 18.75 km squared. Okay, so in this case 2.5 squared, you're talking about km squared here. Okay, but that's just a side note, but the actual answer is present right over here. So the conclusion is an area of 3 cm squared represents an area of 18.75 km squared on the island. Okay, that's the understanding for this question. So that completes this, and we'll move on. So this is the next question. We are given the following figure. It's actually a prism with a cross section of PQRST, and the length is 20 cm. Now PQRST is made up of a rectangle, PQRT, and a semicircle. RST, with PQ is 6 cm and QR is 5 cm. Now we are asked to calculate the area of the cross section. Of PQRST. Okay, that's a question. Now let me draw the given prism. Figure is not to scale. I'm only giving an approximation. Okay, so this is, you have an arch there. Okay, it's a semicircle, and okay, so that's a rough depiction. So now what we have got here is we got the PQ, this length is 20, and you have the R, T and S. Now clearly RTS or RST is a semicircle. Area of RST is going to be pi r squared divided by 2. Now area of the rectangle, okay, PQRT is length into width. That's a formula. We have 6 cm here and we have 5 cm there. So in this case it's going to be 6 into 5, which is going to be 30. Now this has to be added with the area of RST. So if we were to calculate the area of RST, so let me go to the next page. So you see here, this is the entire length is 6 units, so that means the radius is going to be 3 units here. Okay, so area of RST is going to be half times pi times 3 squared, which is going to be 9 pi over 2. So therefore area of the cross section cross section, okay, I have to place a S there. So that is going to be area of the semicircle plus area of the rectangle. So area of the semicircle is 9 pi over 2. Area of the rectangle is 30 units or 30 square units. So taking the LCM is 2. I hope you're watching this. You have 9 pi positive 60. Now I take pi to be as 3.14. Okay. So 9 pi is going to be 9 multiplied with 3.14, which is going to be 9 4s are 36, 3, 9, 10, 11, 12, 1, 9 3s are 27, 28. So 28.26 plus 60 divided by 2. This is going to be 8.26 divided by 2, which is going to be 4413. Okay, cm squared, square cm or cm squared. This is the required area. Okay, so you can have a look at it. Now we got one more part for this particular question. Now the question says, I hope you had a clean look on this particular question. So now what we need to do is we need to go to the next part. The next part states that an engineer needs a similar prism okay, whose volume is not more than 900 cm squared. Okay, estimate in cm the length of the longest prism he can choose or he can use. So the volume is given by the formula area of the cross section times the length. Now we are given that the volume, okay, so we are continuing this question. We are given that volume cannot go more than 900. So we take volume to be as 900. Take it as 900. Now area of cross section is 44.13. We know that area of the cross section is 44.13. Volume is equal to 900. Hence we have 900 is equal to 44.13 multiplied with L. Therefore L should be 900 divided by 44.13. You can use your calculator and find the value out. So 900 divided by 44.13, 20.39. L is 20.39 cm. Okay, so this should be the value for L.